what is vaccine effectiveness? And what does it mean when we say a vaccine is 90% effective versus 80% effective, and so on? Let's use a real-life example and do this wrong first and then correctly. In Colorado, from July 1st through 24th, there were 10,454 COVID cases diagnosed. Of those, 8,380 were unvaccinated and 2,074 were vaccinated. Now, if the populations of both groups of people, the vaccinated and the unvaccinated, are equal, you can see that the number of people who were vaccinated that got diagnosed with COVID is about a fourth of the number of people who were unvaccinated that got COVID. And in fact, if you divide these numbers like a ratio and turn it into a decimal and then a percent, I could say a fully vaccinated person's probability of being diagnosed with COVID is 24.75% of the risk of the unvaccinated person. So this percent represents the risk of the two populations compared to each other. Therefore, I would say the vaccine is 75.25% effective. However, these two populations, the total populations of the unvaccinated and vaccinated, aren't the same size. So we can't simply divide the two raw numbers and figure out the effectiveness of the vaccine. We need to scale them to the size of the populations they represent. In order to calculate the actual effectiveness of your vaccine, you have to scale the numbers of people who were diagnosed with COVID to the actual size of the populations that were vaccinated or unvaccinated. So in my state, 54.16% of the total population is vaccinated fully. And then we'll call the other 45.84% of the population unvaccinated. Some of them may be partially vaccinated, but this is what we'll call them. Let's pretend that that represents a population of 100,000 people. It turns out it doesn't matter how big you say this population is. You could even say it's a population of one person, but it's easier to wrap your head around if you imagine it's an actual town. So let's say in this fictional place of 100,000 people, that would mean 54,160 of them are vaccinated and 45,840 of them are unvaccinated. I just took those percents of 100,000. So then, in order to scale the percents properly, you take the number of people who are diagnosed with COVID but unvaccinated and divide that by the population that's unvaccinated. So 18.28% of the unvaccinated population was diagnosed with COVID. Same thing with the vaccinated population. You take the number of people diagnosed with COVID who were vaccinated divided by the total number of people who are vaccinated. And so 3.8% of that population was diagnosed with COVID. Then you take that ratio and turn it into a percent. So you take the probability that you've been diagnosed with COVID while vaccinated and divide it by the probability that you've been diagnosed with COVID while unvaccinated. If you divide those two numbers, then you get a ratio. The unvaccinated person's probability of being diagnosed with COVID, their risk, is 21% of the risk of the unvaccinated person. So I would call that vaccine 79% effective, 100 minus 21. So there is a general formula that you can use to calculate the effectiveness of the vaccine and the relative risk. The formula looks like this. You take the number of people who got COVID while vaccinated and divide that by the total number of people who are vaccinated. Then you take the total number of people who got COVID while unvaccinated and divide that by the total number of people who are unvaccinated. In each of these, you can use the raw population numbers or you can use the percents. It doesn't matter as long as you do the same thing in both quantities. And then if you divide those two quantities, that gives you the relative risk of the vaccinated people compared to an unvaccinated person. If you do 100% minus that relative risk, that's how effectiveness is calculated. So one more example using some real numbers from Colorado. These are our hospitalizations in July. In July, 638 people were hospitalized with COVID and those people were unvaccinated. 92 people were hospitalized with COVID, vaccinated. So following the formula, you take your 92 vaccinated people who were hospitalized, divided by 54.16% of the population. Just do 54.16, it works just fine. And then you get this ratio, 1.699. Do 638 people who were hospitalized unvaccinated, divided by 45.84, that's the percent of unvaccinated people in Colorado, and I get the ratio of 13.92. If I take those two quantities and divide them, I get the number 0.122. That means that a vaccinated person has 12.2% of the risk of the unvaccinated person of being hospitalized. So if I do 100% minus that, that means the effectiveness of the vaccine at preventing hospitalization is 87.8%. It's 87.8% effective at preventing hospitalization using this real-world data from July. So in closing, what does it mean when you see a statement like, this vaccine is 88% effective at preventing COVID disease? That means that you take the 88% and subtract it from 100%, and now you know that the vaccinated person is 12% as likely to get COVID disease as the unvaccinated person. You have cut their risk by a huge amount, so now they're less than a sixth as likely to get COVID disease as an unvaccinated person. The vaccines are effective, but not 100% effective, means that there will be some breakthrough cases, and it's really helpful to understand what population of people is being talked about when they talk about the percent effectiveness. If it's everybody who's vaccinated and unvaccinated, or only people of a certain age, or only people with certain pre-existing conditions, or whatever. Really pay attention to the language and the populations that they're talking about.